right, everybody, here's the key to Unit 6 or Unit 4-6B notes. And we're having a conversation between standard form and vertex form. Remember, standard form is where we have decreasing intervals of x, and then vertex form is where we have the graph or the equation in a format so that I could see the transformations and I could see the vertex. And remember, vertex form works for any power, so it doesn't matter what n is, that's always going to be that vertex, that middle point of the graph. Same rules about A, stretching or compression, or stretching, compressing, or reflecting. H is going to move it left, right. K is going to move it up, down. When we look at important features of all of our graphs, we're going to have a conversation about domain and range. First of all, we can always, with functions, put anything in. So you're always going to have positive, negative, infinity. Your output for odd functions like x to the first and x cubed is going to always be, output can be all real numbers. Now when you have an even function, you need to realize that that's where the output matches. So you're going to have to, for your output, look at where you have that minimum or that maximum and look at where the lowest minimum or the highest maximum is going to change your output. These polynomial functions are always continuous, and if they're one-to-one, it depends, and you're going to have to do the horizontal line test. Sometimes if they're not bumpy, they pass. If they're very bumpy, they don't pass. When we talk about intercepts, remember, always look for an input of 0. A lot of times, if you go to your table of values at the calculator, that'll help you find that answer easily. And your total number of zeros is always going to be the same as your degree. And you can check to see whether they are real roots, double roots, or imaginary roots that don't ever cross the axis. When we're talking about extrema, all minimums and maximums have this one generic term. And we can take a look at where increasing and decreasing behavior happens. And these local maximums or local minimums determine where the increasing intervals and decreasing intervals change back and forth. Your increasing and decreasing intervals are separated by those local minimums and maximums. And it's increasing where the slope is positive, where you're rising as you move left to right, and decreasing is where it's negative, where you're falling from left to right. If they're even functions, they have the same end behavior. Odd functions have opposite end behavior. Okay, so first of all, make sure you always enter these equations into your calculator and look at a picture of the graph. I can see this vertex here happens at -4, -1. I can graph it, but I went ahead to my graphing calculator, and that's where I got these other two values from by looking at the table and graphing those. My domain and range are all real numbers because it's an odd function. In my real 0, I was able to get from the calculator. Also, my intercept came from the calculator. The graph is continuous. It's one-to-one. And there are no extremas because this is not a bumpy graph. I don't have a change in increasing or decreasing. I'm always increasing. I'm never decreasing. My end behaviors are opposites because, remember, it's an odd function. All right, let's take a look at the back. My domain is, of course, all real numbers. It's continuous, yes. My range is going to only go up to 0. So pay attention to here because see how the graph doesn't ever come up into this area up here? Which means that my range is from -infinity up to and including 0. I'm allowed to include the numbers on my ranges, but not my intervals. So when I go ahead and I look here, I can see these extrema, these local maximums. So what ends up happening is my graph changes, increasing or decreasing at those maximums. So I'm increasing from negative infinity up to 2. I'm decreasing from 2 to 3. I'm increasing from 3 to 4. And I'm decreasing from 4 to infinity. Remember, these intervals are always a conversation about x. When I look at my zeros, I can see them here at 2 and 4. And because these bounce off the axis, I know each of these are double roots, leaving me with 0 imaginary zeros. I get my intercept from the table, and I can check out my end behavior. Both graphs are continuing down towards negative infinity forever. All right, here's our next graph. Because I know it's a cube function, I can see my 1, 2, 3 zeros. And when I look at the calculator, they're going to be irrational numbers, so we're not going to bother finding them today. I just know they're there. My domain is all real numbers. Yes, it's continuous. My range is all real numbers because my output goes from negative infinity all the way up to positive infinity. No, it's not 1 to 1. This is a bumpy graph that fails the horizontal line test. So no, it's not 1 to 1. And again, I can talk about my local maximum here at negative 1, 3. My local minimum at over positive 1 down 1. And those 2 points are where my graph changes, whether I'm increasing or decreasing. So I'm increasing up to that maximum, and then I'm falling. And then I'm increasing again after this minimum. So there are no imaginary zeros. I can see my y-intercept, and my end behavior, of course, is opposite because they're going in opposite directions. All right, good job. Thanks for watching.